So this afternoon, we're going to be talking about genomics data in HealthShare. This is a project we started a few years back, and our original goal was to give clinicians tools to review genomics reports because it couldn't be stored in our EHR system at the time discretely. So we took a look at HealthShare, and it was a good candidate for us to use because it's supported for storing genomics. It allowed for custom clinical data, plus we had the experience and expertise because we had Iris for Health. Our initial use case is we were getting foundation medicine reports from foundation medicine, and so we were getting a history of these reports. And we thought that the final report would be a good model for an interactive UI. The systems involved are HealthShare. This is where most of the work was done. We made changes also in Epic, which is our EHR system, and we worked with Foundation Medicine, Tempus Medicine, and then later on, Genomics. So these are our go-live dates. This includes onboarding time. So for Foundation Medicine, we went live on March 2020. For Tempus Genomics, October of that same year. And in the following year, in March, we went live with Genomics. Now, we made some minor tweaks along the way since those go-lives. And plus, we're having Guardant come on board. And that's another lab that we're working with. So we're going to talk about the data model. We're generating summary document architecture data from the results that we get. So from each of the labs, we either get an XML or a JSON formatted file. And the data model is defined by the sender. So each of these labs sends their own data model. And formatted results are in PDF format. The report is a mix of discrete results or discrete data as well as text-based results. So we're making use of the standard SDA that's for discrete results at the gene level. We're also making use of the hidden genomics order for the text-based results specific to genomics. We are tying everything together by creating an encounter, and we'll see that in a little bit. And I want to point out that we are not storing the variant call format, the VCF data, or the binary alignment BAM data. So here you see on the top left the patient object, and on the bottom right you see a key. That key, anything in green is standard SDA. Anything in yellow is something that we've extended. And anything colored in blue are the custom objects that we've created. And later on, for other test types, we have the purple. So as we go through the next few slides, you're going to see the colors change for the objects that we're displaying. So demographics and identity information go into the patient object, and we see that over here. We create an encounter, and part of the encounter, we include the ordering provider, which is an order provider from UC Davis Health, and we also include a pathologist that is creating the report. We're keeping track of the ICD-10 code, and that goes under diagnosis. And for the PDF that comes along with XML or JSON file, that goes into the document object. So you'll notice that everything is green at this point, everything's standard. So we made a design decision to keep everything at the gene level. So that makes us make use of the lab order with atomic results. And we also made a design decision to have use a genomics order as much as possible. But some of you may know that the genomics order can only store image or text results. So we created XDA extensions for these two orders. If there was a field that wasn't in the order, the standard order, or the results, or the result items, then we knew we needed to create an extension. Many of these elements that weren't in the standard objects, they required a complex data type. Plus, it required additional hierarchy to accurately represent the data. So looking at the lab order, so we're storing at the gene level, and we're putting that under lab result items. And for the genomics findings by gene, we're tracking that as individual tests on a genomics panel. And that allows for easy aggregation of patient data with their genes. All right, and then over here, sometimes they send detailed information, and that goes under the comments. And we're also extending the lab order to include extensions. And we have an extension here for therapy. So what we're seeing over here is the name and the 3 other fields that we're capturing. We're doing the same thing for clinical trials. Clinical trials is one of the other custom objects that we've created. All right, looking at the lab order still, so anything that's kind of related or indirectly related to a gene, that goes under the extension. And we're extending scientific studies that are tracked by number. And also, we're tracking the variants of unknown significance. These are genetic mutations that were identified, but the effects are unknown. And then we have the variants, we have the biologically relevant variants in addition to the variants of known significance. So this came later. You'll notice that that is in purple. So switching over to the genomics order, we are, I'm going to sit. I need my other pair of glasses, so hang on. I'll just sit for a second. So for the genomics order, we're looking for specific genes. That includes a list of variants. And then we also extended the genomics order, and part of that is the biomarkers. So you see on the bottom left there are the biomarker fields. And we also extended the results. And that includes the result details as well as a test summary. Part of the test summary, these are fields that are not discrete. These are just fields that include the test summary, interpretation, and any clinical significance. We also are capturing quantitative elements of the result. And you see here, these are all the fields that we're capturing. And some of those fields are key value pairs. And those are noted on the diagram. Right below that, we have the probes. And probes also needed an additional hierarchy so that we could actually represent the data. And that too also has a key value pair. So all these changes are everything that we did to store the data that we wanted from the 3 different labs. All right, let's talk about a user interface. We registered a Smart on FHIR application in App Orchard. App Orchard is now known as App Market. And part of that, you get a client ID from Epic. And we take that client ID, we put it in the integration record, which is the FTI record in the EHR, and we also added in a redirect URI. Now, correspondingly, on the HealthShare side, we updated the OAuth2 client to configure that with the same client ID and redirect URI. Now we have customizations that were done. So we did a custom launch page which extends OAuth2 login, that class. And we have customization for HealthShare delegated authentication. And we have a patient lookup process that's customized as well for the clinical version, clinical viewer version 2. So let's take a look at that scenario. So here, a provider is logged into a patient's chart in the EHR, and they launched the Smart on FHIR application. And this is done by clicking the Genomics report menu item. So that establishes a session into HealthShare, and both HealthShare and the EHR, which is Epic, use OAuth 2.0 to perform the single sign-on onto HealthShare. HealthShare then validates the token and API key and upserts the user into the clinician registry. What happens next is that HealthShare then uses the access token and the FHIR ID from the token response to retrieve the resource of the EHR FHIR repository, the patient resource, to get the medical record number and the assigning authority. HealthShare then uses a HTTP 302 redirect, and it brings the browser to a class which automatically searches for the patient, fetches the SDA, and redirects into the clinical viewer. The clinical viewer then displays the patient's available genomics reports. So a few words about the single sign-on and the UI itself. So the single sign-on process is completely transparent. There is no searching for an additional patient or separate authentication. The list itself is styled after the look and feel of our EHR, so it looks pretty seamless to them. Behind the scenes, we're going out to another system, to HealthShare, and we're bringing that data in, but to them, it feels like it's just one system. The report itself is modeled after the PDF sent by Foundation Medicine using the final report. And the nice thing about this, what we did here, it's interactive. There's external lookup capabilities for APIs from the National Institutes of Health and the National Library of Medicine. For medication therapies going through PubChem, and clinical trials going to clinicaltrials.gov, and user-friendly information on specific gene conditions from Medline Plus. We have a REST API, and that REST API is a standard API that fetches SDA data loaded on the clinical viewer. It serves the PDF to the UI. It also transforms SDA data into JSON for the UI's data model. Plus, it also proxies requests to public and government APIs. Now, the user interface, there was no genomics order chart that we could use appropriately in the clinical viewer. So we created an Angular app that we put and embed as a custom chart in the clinical viewer version 2. Now, as we've seen earlier, the SDA model is a combination of several SDA objects. And the data found in other CV charts, that is covered by our EHR system, which is a source of truth, and we're just reaching out to HealthShare to retrieve the genomics information that we have stored. And plus, it wasn't in our initial use case. All right, here's a short video of everything in action. And I'm going to just talk through this. Here, when the EHR, we're going to go select a menu item to bring up genomics. Here, we're doing the single sign-on. And what it will return is a list of genomics results for this patient. I'm going to select one of these. I'm selecting it. This is the details of that. The white portion is the header. This is the PDF that goes along with it. First tab provides information about the gene. Everything on the left is a gene. More information shows up on the right. And these are the references, what I'm highlighting over here. The next tab is clinical trials. You can screen this out by entering a location. And you could restore that back by clicking reset. Now, these two links over here, these are links to retrieve more information. And if you're looking at this at a later date, you can find out the clinical trials at that HealthShare link. This is the last tab. It's for variants and biomarkers. This is the information we captured here. And clicking on this arrow here brings us back to the list. All right, so that video was taken from our test system. And one thing that the video didn't cover is this. So this slide over here is pointing to flora uracil, and you could tell that this information came from an external resource because of the last two lines at the bottom right. Same thing with this. This is looking at gene TP53, and the information on the right also came from an external resource as indicated on the last line on the slide. Now let's switch over to utilization management and notifications. Now we monitor utilization via custom HealthShare management on the ATNA log. And ATNA is audit, trail, and node authentication. We're tracking the user activity. We're tracking the patients requested by user. And we are also tracking the success rate, whether the patient has genomics reports or not. Now, the research team has the same access to the files that we get. However, they use their own tools for conducting research. If they wanted to go into the EHR and view the tools that we've created for providers, they can do so as well. Here's a sample dashboard that we have for user activity and inbound report volume by sending lab. And each color that you see here is representative of each of the labs that we worked with. When Guardant comes on board, there will be yet another color on this chart. Now for in-basket notification, when we receive a report, we trigger a notification to the provider. Now sometimes all the lab sends us is the provider's name. And when that happens, we make a series of API calls to make sure that we notify the right provider. So let's take a look at that in a little bit more detail. Here, HealthShare searches the EHR FHIR repository for a practitioner just using the full name. If we find exactly one match, we take that NPI and make a standard, not a standard, a custom EHR API call to get the provider's EMP-ID. And then the standard API call happens once we have that EMP-ID, and we send a notification to the provider that a new genomics report has been processed for this patient. So what happens next is that when a provider is in their in-basket, they open up a folder named Genomics Results. They see that they have a new report in there. They click on that report, and part of that, the details of the message is a link where they can view the genomics reports for this particular patient. And that's how the provider knows that there's a new genomics report available. So there were a lot of teams involved, UC Davis Health, I being one of the developers on the team. Many others have contributed. We worked with J2 Interactive, our consultant, Paul Robbins. He couldn't be here today, but he was very instrumental on getting a lot of things done. And we've been working with InterSystems from the beginning up until the present day regarding this project. Here's my contact information, Asercion@ucdavis.edu. And in closing, I just want to say this. We focused and created this for genomics data. However, we can use this as a template for any clinical data that's not discretely available in the EHR. And thank you for being here. Thank you for your time. We could open it up for questions. Any questions? Yes?
For the great presentation, so we are starting from Celestinus, the incubator of InterSystems. We are interested about, but do you analyze the raw data, I mean, like FASTQ files, FASTA files, or you don't work with such data?
Which files are you talking?
FASTQ.
Oh, FASTQ. Oh, yeah. No, we don't. So the files that we get are formatted. It's really XML file or JSON files based on the PDF that we got. So it's a PDF representation of what we have, but it's expressed in XML or JSON format. So we use that data to.
How do you extract it? I mean, you extract it manually from PDF file or automatically?
Yeah. So we get a PDF file. Alongside of that, we get the corresponding JSON or XML file. So the two are kind of mirrors of each other. So we take that PDF file, we store it, and then we also take what we have. If it's JSON, then we take that and put it in the SDA and retrieve that to be represented as a Smart on FHIR application on our EHR. So that's how it works. So yeah, so the file that you mentioned, no, we're not working on that. Yeah.
So Foundation Medicine report, many years ago when we started the project, they actually provide the XML file and that contains all that as a byproduct. It sort of goes along with the PDF. Yeah.
Well, the PDF is also the formatting that clinicians are used to. So when they want to look at a report with all the colors and links and all that sort of stuff, they can click on that link that's available within HealthShare on the Smart FHIR app, so they can see a format that they're used to. But the discrete data results that are filed are the way that we're filing them inside of HealthShare to give that a more flow sheet view, which is what they're used to in their EHR. So,
Thank you for the explanation. Thank you so much.
Any other questions?
No questions? Can I ask?
Yeah, sure. Yeah, go right ahead.
Also, you are working with pharmacogenomics data, I mean, with target therapy, like in oncology. But do you work with, I mean, UC Davis, do you work with other pharmacogenetics data, like different
proteins or
yeah.
proteins,
or pharmacogenetics?
Pharmacokinetics.
Yeah, from general medicine.
No.
Because, for example, I'm ex-postdoc of UCSF, and now we just started our project with general pharmacogenetics. I just wanted to ask your experience.
Oh, is that a lab that you're talking about? A specific lab?
Yes, this is the project of many labs. And, yes, we finally started last month, and just wanted to know your experience with that. Yeah.
Yeah. So,
we haven't done anything with pharmaco yet. We're not getting any of the basically the reports we're getting are just from the cancer side. So from those three vendors. So at this point we aren't pulling in any other genomic reports that we file somewhere else. So I mean, in Epic, the pharmaco stuff, they actually have a place for that to go and actually give you some of the feedback. Part of the design here was there at the time, 4 years ago when we started this, there wasn't a real place to show discrete results. Just attach a PDF. So part of that was pulling that in and giving a much richer view to the data. But at this point, part of the organizational demand hasn't gone to any other vendors providing that level of data. But if we were to get pharmaco, depending on what we want to put in Epic and what kind of metabolizers and some of the other things that you get out of CDS or out of functional support out of Epic, then we'll have to drive that way. But that's not something that's been a priority at this point.
Yeah, so Michael is from UC Davis and has
That's
been
my director. Yeah.
supporter for this project, really overseeing this at the higher level and from the beginning. My answer will be actually Marvin went through a very detailed methodology about using existing SDA object model, but also extend it. So you can do the same thing by extending it. There's all kinds of techniques you can extend it by extending model, create additional objects, and so on. So you can do the same approach and offer some flexibilities. And unfortunately, there isn't any sort of golden standards out there, and you have to do it fit your organization's need. And I recognize you're also a startup company. You want to create something that's a little bit more scalable, repeatable, and so you do have the full capability to extend the SDA data model to store those data too.
Yes.
So apologies for coming in late, but am I correct in assuming that you're talking really post-analysis data, right? You're not drawing in raw genetic data, is that correct?
Yeah. So these are results already that has been analyzed, and
We do
it's final.
VCF files, and so we do get that back as well. So not only are we getting the report view that you have, but there also is the repository for those banned VCF files.
So you could theoretically do further analyses.
Could.
You built your own pipeline to work with VCF file,
I mean, at this point, the request was to get the file. We haven't, in the HealthShare environment, done anything with it other than pick it up and store it. so it's there for anybody to use, but we haven't done anything with HealthShare.
Yeah, we have done some work before, many years ago, with Mass General, and to store the full extent of a VCF file, including those does not have a clinical significance yet, just for research purposes. But they require using the BAM to create the VCF file with the molecular pathology team to do a sign out. So we're not participating in that part. We're just taking the output. But the raw VCF has a lot more detailed information, which there is a project extend HealthShare to support that as well. So you could look into that, and we have some information we can share with you.
We also have a project where we're storing waveforms, so we're looking at other advanced imaging and having a home for that. And again, the idea here is that we build an entry point or a punch through so that data not stored in Epic can be made visible in a patient's chart inside of it, which is basically the home for everything. So what we're trying to do is create a mechanism for, even as we talk, research and AI and all that sort of stuff, is how can I get a feedback loop that presents data to the clinician? And so what we've created is that kind of path, and now we just add functionality onto that based on what some of the use cases the organization wants to deploy.
Great.
Great. Thank you very much.
Let's go to the party.
Yeah.